Okay, question 12. A student measures the density of glass. We're talking about density. The student has a bag of marbles, all made from the same type of glass, a weighing balance, and plastic measuring cylinder containing water. Describe how the students could find, as accurately as possible, the density of the glass used for the marbles. So immediately we're thinking about density. We should remember the equation. Density is the mass over the volume. Okay, so the density is the mass over the volume. So to find the density, we need to know the mass and the volume, and we're there. Now, there's a clue here. We've got a bag of marbles. We could just do it with one marble, but it does say as accurately as possible. So to reduce any uncertainties, we're going to use all the marbles together rather than just doing one. And I wonder what else we could do to make it as accurate as possible. So let's work it through, shall we? So firstly, we're going to say use the equation. I'm going to abbreviate here. Density is mass over volume. That's a symbol rho. It looks like a kind of a slanty P. It's the Greek letter R, which is for density, is mass over the volume. Use the equation to find the density by, let's put 1, here we go. So we're going to use the balance to find the mass of all the marbles in the bag. So we're going to put the bag on there. We use the mass to find, notice we use not the amount, but the mass of all the marbles in the bag. To then find the mass of the bag on its own. 3, subtract the bag's mass from the marble and bag to find the mass of the marbles alone. Okay, so practically speaking, you're not going to be able to put all the marbles on a top hand balance and they're going to stay there. So we put the bag of them on there, got the mass of all of them, and then taken away the mass of the empty bag to get this value here, the mass of the ball. So number 4, the volume. There's a clue here. You might remember if we had a beaker, sorry, a measuring cylinder with, say, 50 millilitres of water in it. We could put the marbles in there, and it goes up to 61 millilitres. The increase is 11 millilitres, or 11 centimetres cubed. So that is the volume of the marbles. Okay, so exactly what we're going to explain here then. So empty, well actually, before we empty the marbles into it, we need to know the volume of water at the beginning. So find the volume of water in the cylinder. Add all the marbles into the cylinder. Little brackets here. Let's think about it sensibly. We don't want to make sure it's overspilling. So we could say make sure there is enough water so all the marbles are covered. Okay, so make sure enough, make sure the water marbles are covered. 6, read the new volume and take away the volume, oh, hello, I missed that, of water alone, to get the volume of marbles. 7, We're going to go mass of the marbles over the volume of the marbles. It's going to give us the density. I haven't done it as accurate as possible. We've used all the marbles. We could have actually said here about finding the volume of the water in the cylinder. We could have put here, find the volume of water. We could be talking about eye level, reading at eye level. Maybe a little thing here with an eye would help. There's my little eye, and we're reading it at eye level, and maybe you could have it on a flat surface. All those kind of things would help with the accuracy.